Welcome to this Higbie Labs product informational video.
Hello, I'm John Higbie. In this video, I'll be demonstrating a material handling application using our Hig Mover miniature smart rotary actuators together with our Scripty programming tool, which allows you to easily sequence motions for multiple movers in response to general-purpose digital inputs on our Hig-Hub bus master. This demo is measuring coffee beans into these 8 cups on this carousel rig, which is mounted on top of a Hig Mover rotary actuator down below. We will load the coffee beans into this clear tube, where we have a second Hig Mover actuator operating this spatula as the gate control for the flow of beans into the cup. We also have a photoelectric eye, this green light here, which will detect the level of the beans in the cup. When they rise to a certain level, that will cause the photoelectric eye to trigger the closure of the gate, whereupon the carousel will advance to the next cup. The program flow is hosted in this Hig-Hub bus master from its internal memory. The Hig-Hub also hosts the GPI inputs for the photoelectric eye and this push button, which will be our start control. In preparation for doing our Scripty programming, I'm going to set up a couple of position presets in the Group Movers tab here. Sometimes it's easier and more expeditious to do certain functions in the Group Movers tab compared to the Mover tab, because unlike the Mover tab, you don't have to select and then upload all those settings individually for each mover. For example, I'm going to refresh the movers, and you'll see that we have movers 1 and 2 became visible here. It's easy in Scripty if you can work with preset positions instead of numerical positions on the encoder. So I'm going to make these part of the preset set and go groups. And I'm going to select positions for the starting position on the carousel and for the open and the closed position on the gate. And I can jog from here. I can jog the motors individually, or I can jog the group. But sometimes it's easy just to push things around by hand. So I'm going to turn off all the motors, and I'm going to orient the carousel to about where I want it. That's pretty good for that. So I'm going to make that set A, that's mover 1 is the carousel, so I'm going to set A over here. And then for the gate, it doesn't want to go completely open. That gives us too many beans, so we'll start by setting the closed position right there. I'm going to make that A, and then we'll set an open position about halfway, and we'll make that preset B right there. And I'm going to save all of those to flash for the individual movers. Now I'm going to re-enable the movers. We'll jog the carousel around a little bit so you can see everything go. So everything now going to the A, and you saw the gate close, you saw the carousel go to the start position. So now that we've got presets, we can go over to our Scripty tab. If you look at our Scripty table here, you can see we've got 4 columns: label, app device, action, and value. Label is where you would put an individual label for that line, which is helpful for program flow instructions, like go to or go sub. App device means which device is going to be doing the action for that line in your program. It could be your program running on the Windows app. It could be your program running on the hub, or it could be a mover performing some action. If I select App Hub, then you will see in the action column your choices include a number of program flow instructions. And they also include outputs to the hub GPIOs. It happens for this first line of code, we want to create a loop, and we want to enter, got 8 cups, so we'll enter a value of 8. That's the first line of our code. You see, we've already got the end line here, the end instruction. This must be present in every one of your Scripty programs. You must have an end at the end, and that's why the Scripty tab populates that for you before you even get started. So let's insert some program lines here. Going to need a bunch of them. Okay, so we're going to loop 8 times, and then right away before we forget, let's put the end loop instruction in. Any loop you have must have an end instruction. That's also under App Hub for program flow control. There's our end loop. So everything in between these two will execute 8 times. So the first thing we want to have happen is we want the coffee bean gate to open. That's on mover number 2, and we want it to open. So we want it to go to preset position, and we enter preset B. We want preset B because that's the open that we just set up. Then we're going to have it watch the electric eye. Again, that's App Hub because we're going to wait for the event of the electric eye turning on, which is on GPI 1. It's wired up to the hub. When the coffee beans have reached their level, the electric eye triggers. Then we want that gate to close right away. So again, it's mover 2, going to preset A, which was that closed position. Then we don't want the carousel to advance until the gate's fully closed. So we're going to wait for that gate to get fully closed. Wait for event. Mover 2 complete. That means as it was completed its action. Then we're ready to have the carousel advance to the next cup position. And so very simple way to do that is just to have it slew a certain number of degrees, which of course is 45 degrees because we got 8 cups. And I know that that's the negative direction, so we'll type in minus 45 degrees. And then we're going to, of course, wait for that to complete its motion before it opens the gate for more coffee beans. So we're going to wait for event mover 1 complete. Mover 1, of course, being what we just set in motion. And that's it. I've got a couple extra lines here, which I can remove. And that's our program. And before we go any further, I'd like to save it. We'll make it coffee 5. So we've had a few rehearsals here. Now we could run this from the Windows app here, run it directly and make the thing go through its whole program. But I would like to actually run it from the hub, and there are a couple of reasons for doing that. You can have a standalone system without the need for a computer sitting there, and also you might find that you get somewhat snappier performance running it from the hub rather than from running from the PC, because you don't have the delays, the latencies imposed by the serial communications link. So I'm going to download this into the hub, save Scripty to hub, transferring Scripty, and transferred. So now we're going to configure the GPI inputs for the photoelectric eye and the push button. These are both wired up to this connector here on the Hig-Hub bus master. The photoelectric eye, you can see on the user interface, is on GPI 1. As I interrupt the light beam, you can see that toggling from green to red. That's actually the inverse polarity for what we need to trigger the event in the Scripty program. So I'm going to invert that at this checkbox. Now you can see it does the opposite. And so that will be when the beans reach level, that will be the trigger. Then we go over to the push button on GPI 2. You can see that toggling there. We're going to set that as the Scripty run control, so it triggers the program start. And we'll make it level sensitive, and that way the program will only run for as long as I'm holding the button down, and that's useful as a dead man switch or emergency stop in case anything happens to go wrong during the program execution. All right, so now we've got our Scripty program loaded into our Hig-Hub bus master. We've eliminated the laptop in favor of the basic push button control. And so now let's load up the coffee beans into the tube. All right, so we've got all our coffee beans all loaded up. Let's push the button and make it go. Okay. Thank you for checking out this product application video for the Hig Mover actuator. I'm John Higbie for Higbie Labs. Cheers.